So current electricity is the third chapter of yours. This chapter, what we are going to learn is 12 important points to do. So I will share this window to you through the WhatsApp. Apart from what is there in the slides, if you want to note down anything, you can just write it down in your paper. So these slides, we will be sharing it to you. Apart from the slide, if you want anything to be written, whatever I am speaking, that you can write it down. So the first point we are going to learn is electric current. We've already done it. Then we're going to learn about conventional current and what it is. Drift velocity, yesterday it was discussed to you. Current density, Ohm's law. So yesterday we saw V is equal to I into R. That will be the Ohm's law. The next topic would be resistance, resistivity, conductance, and conductivity. So all these questions can be asked for 2 marks. Then we are going to see how temperature depends on resistance. After that, we are going to learn about color codes. This is an interesting topic. Then we are going to learn about series and parallel combination of resistors. We're going to learn about EMF and potential difference of a cell. Then we'll see what is the internal resistance of a cell, series and parallel combination of cells. So these are the topics which we're going to cover in this chapter. After that, we have few more derivations to be done that will be taken up. So we'll get into our lesson. The first thing you're going to learn is what is your yesterday's Ohm's law, what we did. For those who are joining today, we will just have a briefing of that and then get into our next class. Yesterday we saw what is Ohm's law. So I clearly told you it is current will be directly proportional to your potential difference. I denotes your current here and V denotes your potential difference. So directly proportional means whenever you increase the current, potential will also increase. Similarly, you decrease the current, potential also will decrease. That is the meaning for it is directly proportional. So the law states current will be directly proportional to the potential difference between the ends of the conductor provided temperature and other physical conditions should remain constant. So we saw I should be proportional to V. Remove proportionality sign, put an equal sign. I should be equal to V divided by R. So you cross multiply, you will get V is equal to I into R. What are these terms? V is the potential difference, I will be the current, and R will be the resistance. This is the mathematical form of your Ohm's law. Now after this, we saw what is drift velocity and what is mobility. So drift velocity is, I told you, like charges will always repel, unlike charges will attract. For example, a positive and a negative, they will get attracted. When we have two positive terms or two negative charges, they will always repel. So here electrons are negative. Where should they get attracted? So they will get attracted towards the positive end. Keep this clear. Electrons which are negative will get attracted or will get drifted. They will move towards the positive end of the conductor. And this direction will be opposite to the electric field. Electric field will always be in the direction of free electrons. The definition for drift velocity is the average velocity with which free electrons will be drifted towards the positive end of the conductor under the influence of external electric field. This drift velocity, if you divide it by electric field, or if you take the ratio of drift velocity and electric field, we get a new term which is called as mobility. This mobility is denoted by the symbol mu. So this symbol is called as mu. So drift velocity is velocity with which electrons are drifted towards positive end. Mobility is, it's the ratio of drift velocity per unit electric field. And we saw the formula, Vd will be equal to I divided by N, A and E. So if you take a conductor, area of the conductor will be A. I will be the current. How many electrons are present? That is noted by N. E is charge on your electron. So charge on the electron is 1.6 into 10 to the power of minus 19 coulomb. You are very clear with this. So chemistry also you learn what is the charge of an electron. So it is 1.6 into 10 to the power of minus 19 coulomb. Drift velocity, general formula is this. So Vd is I divided by Na and E. If you have other terms, for example, in terms of temperature or in terms of pressure, if you want to write the drift velocity, we have different formulas. I will discuss regarding that in the following slides. So I think this is clear. What is Ohm's law? What is drift velocity? What is mobility? And expression for drift velocity. We already saw this yesterday. So I just wanted to brief it for children who are joining today. Now coming to electric current, I told you what is electric current yesterday. If you can just recall, electric current is nothing but, you can see the formula here. This electric current is the charge flowing through any section of the conductor per unit or per second. We call it as the electric current. So here you have the electric current to define as the charge flowing through any conductor or through any section of the conductor in 1 second. This is one definition. If you feel this is difficult, the second one is rate of flow of charge. So that's easier to learn. What is current means? Just one line. It's rate of flow of charge. That is called as your current. And the formula is I equals Q divided by T. I think you should remember Q is your charges, T is the time, I will be your current. Now if there's a change in charges or there's a change in the time of your current, then your formula will become I equals dq divided by dt. So both the terms are correct. dq divided by dt means there's some change in the charge and some change in the time. D difference denotes your differential. So keep this clear. Electric current, one line definition, rate of flow of charge. If you want to define it clearly, it is the charge flowing through any section of the conductor in 1 second. So if there are 5 charges flowing during 5 seconds, your current will be 5 by 5, which will be equal to 1. So that is how you have to check. Rate of flow of charge is called as your electric current. Now there should be different types of current, you already know. One is your direct current, the second one is your alternating current. Now we will see what is meaning of convention current. So if you plot a graph by taking I on your y-axis and T on your x-axis, current here, and this will be your time. So if you are connecting that way and we can draw a graph, then you can see that you have a straight line here that is denoted by the symbol A. So that type of current is called as steady current. So what is the steady is, this current does not vary or it does not change with time. So if there's a current which remains constant with time, we call it as steady current. What is the meaning for steady? It should not change. It should remain constant. So the first type of current is steady current. It does not vary or it does not change with time. The second graph you can see, it is starting from the origin and it is increasing, and it is increasing in a straight line. So this type of current is also called as a steady current and it varies with time. For the first second it is here. Say for 5 seconds it has gone up to this point. So any current which changes with respect to time, we can draw this straight line, which is the graph denoted by the symbol V. So I will give you these slides at the end of the class. You just know what is what. A is steady current which does not change with time. B is the steady current which changes with time. Why I call the steady current is you don't have any curves here. It's just a straight line. So keeping the straight line, you can see that this line B is increasing, whereas A is horizontal. So what we can do is A is steady current which does not vary with time, and B is the steady current which varies with time. Look at the graph C. It is not a straight line. you have ups and downs. So that is called as varying current whose magnitude varies with time. So with time, the magnitude of the current also will vary. That is, it will increase and it will decrease. So A, steady current, no variation with time. B, steady current with variation in time. C is varying current. Varying is changing current which changes with time. And the last one you can see, we have a up and a down. A complete wave is formed. This type of current is called as an alternating current. So what is alternating current is? Its magnitude varies continuously. First half it is increasing, second half it is decreasing, again the third half it will increase, the fourth half it is decreasing. So continuously it is changing with respect to time. And you can see this distance and this distance are same. So this type of change we call it as periodic change. If it is happening periodically, that's the difference between graph C and D. C, somewhere it is increasing, somewhere it is decreasing. But D, if you see, you have that uniformity. That periodic increase and decrease is called as alternating current. I'm repeating it. Straight horizontal line, steady current which does not change with time. B, from origin it is increasing and it's a straight line. So it is steady current which changes with time. C, it is varying or changing current with time. And D, the red color you can see is called as the alternating current. So this will be asked for 1 marks if you want to learn up. But majorly we classify current into steady current and varying current, alternating current, the other one is direct current. Now what is this convention of current? Convention current means in what direction current can move. You can see a conductor here. One side we have positive terminals, red. The other side you have negative terminals, which is B. So positive charges are in plus sign, negative charges are with minus sign. If you take any electronic device and you want to connect a terminal, red color will be in positive, black color will denote the negative. So if you take an ammeter or a galvanometer, when you do your practicals, all red terminals, keep in mind, they denote your positivity. Black terminals will denote that they are negative. So you know electrons are negatively charged. So all these negatively charged electrons are moving towards the positive charges are moving towards the negative charge. So we can see that here I put only plus signs. What you can see is the charge. And this movement of the charges, we are moving towards the negative side. What is the reason? Always negative charges will attract your positive charges. So if your negative charges are attracting your positive charges, charges start to move. So when charges are moving, automatically current will be produced. And if current is produced, it is denoted by the symbol I. And you can see this arrow mark that denotes the direction of the current. It is moving from the positive towards the negative. So you see this clearly. These plus charges are positive charges. These are negative charges. So what you have to observe here is the negative charges are attracting the positive charges. And in whichever direction the charges are moving, current will be produced. So what is this conventional current is? It is the current whose direction will be along the direction. It is in the same direction of the positive charges. You can see positive charges are moving from positive side to negative side. Arrow mark of your current I also is in the same direction. So conventional means direction of current and direction of positive charges are same. They are in the same direction under the action of electric field. We'll see a difference now. See, we have interchange. First side we have negative charges. The second side you have positive charges. So when you have negative and positive, just see what's happening. Negative charges are moving towards the positive side. And you can see the direction of I. Direction of I is in the reverse direction. See the first diagram? I is also along the positive x-axis. Charges are also moving on the positive x-axis. Second diagram, I is interchanged, whereas charges are moving in the positive direction. So conventional current due to motion of electrons. First what we saw is due to motion of positive charge. So due to electrons, it will always be in the opposite direction of the electrons. So looking at the diagram, keep this clear in your mind. If we are considering the movement of positive charge, then charge movement and current direction remain the same. Second case, if you are considering the direction of your electrons and the direction of current, then they will be opposite. Now, general rule here is current is always flow of charges. Current direction conventionally will always be from positive to negative. So whichever side we have positive line, from there only it will move on to the negative side. So in the first diagram, from right to left it is moving. In your second diagram, it is moving from left towards your right. So keep this in mind. Your direction of the current will always be from the positive side towards your negative side. Drift velocity and current. We again have this definition here. Who's Galaxy J2 2016? Kindly mute your phone. So drift velocity definition is already told to you. Velocity with which electrons are drifted. Just look at this diagram here. This is a conductor here. So whenever you have a conductor, I will be the total current which is passing and L will be the length of your conductor. A will be the area of cross section of your conductor. You have a battery here. One single positive, one single negative, we call it as your cell. If you have more than one, we call it as a battery. So combination of cells is called as a battery. We'll connect it to the conductor. So you can see it is connected towards the ends of the conductor. Electrons are moving in the opposite direction. Electric field is moving in the forward direction. So you can see the direction of current. If current is moving forward, your electrons will always move in the reverse direction. So that's the definition for your drift velocity. We saw one formula there. The remaining formulas here are, if it is in terms of temperature, Vd will be equal to A into T. These will be using to solve your sums. So Vd in terms of electric field, drift velocity is small e capital E divided by m into T. This is a formula which we saw earlier. I equals NEA into your drift velocity. So from all this, what we can conclude is your drift current will always be proportional to drift velocity. That is, if you increase your current, automatically your drift velocity also will increase. Keep this diagram in your mind. Current is forward, electrons should always be in the reverse direction. So what are the terms here are defined for you? Vd is drift velocity, A is acceleration. You can see the symbol here that is called as the relaxation time. It's a Greek symbol called tau, T, A and U. E is your electric field. Small e is electronic charge. M is mass of the electron. Your assignment, in your chat box, you can give me what is the mass of an electron. You know it very well, think, and you can put it in the chat box or in your WhatsApp group. That's your question. First three answers, we will announce the names tomorrow. I want to know what is the mass of your electron. Charge, you already know, it's 1.6 into 10 to the power of minus 19. So, or type the value for mass of electron and just pass it on, either in the group or in the chat box which is available next to you. First three answers I will announce. N is number density of electrons, L is length of the conductor, and A is the area of cross section. The next definition, hereafter three definitions I'm going to do, and all these three definitions are important for 2 marks. First one is your current density. Density means, now you take a bench. A bench has a capacity of 5 students. 5 students can be seated in the bench. If all 5 of them are sitting, I call that bench to be completely dense. It's completely filled. If only one child is sitting, that means the density of that bench or the capacity of that bench is lesser. So few more can sit in the desk. Density is low. So you just compare the students to the molecules now. We take any metal. If it is completely filled, it's jam-packed, no more additionally can come and sit, then we call it as more, or the density is greater. If it is here and there, then we use the term the density is less. You should have come across this dense forest. Trees will be more there. So we call that as dense forest. Current density. So from these examples, you can clearly know current density means it should be within a conductor. It is a current through unit area of the conductor. So we take a small region. Unit area means 1 meter, this side and that side, around that point. So you take a point, surrounding that point for 1 unit area, how many electrons are present? That is the meaning for current density. So it is within the conductor. How to define current density is, it is the current through unit area of the conductor, and you should consider a point. So if you have any one point there surrounding that point, 1 meter this side and that side, how much of current is produced? That is called as your current density. One condition, the area should always be perpendicular to the direction of flow of current. So this current density formula is, it is noted by J. Keep in mind, I is for current, J is for current density. So formula is I divided by A, or you can write it as NE into VD. In vector form, I will be equal to J dot A. J is current density and A is your area of cross section. Ohm's law, yesterday whatever we saw the statement, the same thing is here. You can see the diagram here. Mathematical form is V is equal to I into R, or you can tell I is proportional to V, or it can be V is proportional to I. So if you plot a graph taking V on x-axis and I on your y-axis, you will get a straight line because it is a steady current. So that is your Ohm's law. We have 10 more minutes, so we'll quicken it up. Resistance is the next definition to do. Now somebody is coming to beat you. What you'll do, you'll keep your hand and stop it. If we want to stop something, there should be a force to stop it. You will use your hand, or you will see some protection is there so that the hand which is beating you doesn't fall on your face. The same way, if current is flowing, it is moving forward, there should be some force which will stop it. That is called as resistance. So resistance of a conductor is the opposition. It is offered by the conductor to the flow of electric current. Now your body resistance should be high. We tell that reason. You shouldn't fall sick frequently. You should have more strength. What are you fighting against? The germs which are attacking you. COVID-19 time, best example to give you. Increase your immunity system. That is what all people tell, because you should be more resistant. When the virus comes to attack you, your body should be in a position to stop it. So that stopping is called as resistance. Here in terms of physics or in terms of electricity, when we study what is resistance is opposition offered by the conductor for the flow of current. That is called as your resistance. Formula is R equals V divided by I. Now if you take a conductor, you can use this formula also here in terms of I here. So all these terms I will share it to you. Just when you're solving problems, you will need all this. Remember, R equals V by I. Its SI unit will be equal to ohm, OH and M. That is the SI unit for resistance. So here, this formula is important, which is in white. R equals, I call this as rho into 1 by A. The resistance will be directly proportional to the length. Length is L. And it will be inversely proportional to area of cross section. That is a relation. You have to remember this. Resistance is proportional to length directly, inversely proportional to area of cross section. And what is the symbol rho? It is called as the proportionality constant, or we call it as resistivity. Only this formula, please make a note. R equals rho into 1 L by A. L is length, A is area of cross section, and rho is your resistivity. You have the formula here. We call it as resistivity, or you can call it as specific resistance. This is what I told you. Resistance is directly proportional to length, inversely proportional to the cross-sectional area, and it depends on the nature of the material. Whereas resistivity, the symbol rho, it does not depend on the geometrical dimensions of your conductor. Now you have the relation between the different terms here. Rho equals E by J or E divided by NEVD. All this is only for your reference. Just note it down. These conditions are important. When temperature increases, what happens is drift velocity will decrease, resistivity will increase. Same way, if current is increasing, your potential or your drift velocity will decrease. This is in relation to whether they are directly proportional or they are inversely proportional. So we finish with resistance. Conductance is the next term. It is a reciprocal. Reciprocal means 1 by R. So conductance is a reciprocal of resistance. Recall what I told you, the SI unit for resistance, it is ohm. I spelled it as OH and M. See the SI unit for conductance, it is the reciprocal. We call it as mho, M, H and O. So resistance is opposition, conductance is the reciprocal of the resistance. So SI unit, keep in mind mho. How we had resistivity, the same way we have conductivity. That is the reciprocal of resistivity, and its unit is mho per meter. Now, what are the factors on which your resistance depends is, one factor is temperature. The second factor is number of collisions. The third factor is your internal energy. The fourth factor is your relaxation time. Now, keeping this, you can learn what is the temperature coefficient. That is RT minus R0 divided by R0 into T. R0 is resistance at 0 degree. RT is resistance at the time T. You can use this formula or you can use this formula. R0 is resistance at 0 degrees. RT is resistance at T degrees. So if you have two things, R1 and R2, instead of 0 degrees, we can use this formula. So this is your coefficient. So if R2 is lesser than R1, then alpha will be negative. We have learned much now.